Hello everyone to the ninth and the last consultation of the functional programming course. This consultation will be structured same as the previous consultation, last week's consultation, which was pre-recorded. So we are going to pre-record this consultation as well. In this consultation, we will go over classes and instances in Clean. I'll dive into that in a bit. Before I start, I just want to state that this video is mainly targeting the students of Eötvös Loránd University in Hungary. However, anyone interested in watching or learning about classes and instances in the Clean programming language is also welcome to join. Before I start diving into explaining what a class really means in Clean, I would like to revise a bit what function signature means in Clean. So if we have, for example, a function, okay, and this is how we define a function in Clean. I hope you still remember that from the first practice, I think. So we have a function, then we can give it a type, any type. We can give it an int, for example, and tell it to output some other type or maybe the same type. We do not care. Um, for example, let's output a string. Okay, so we have a function that takes some input, an integer to be specific, and returns an output, a string, an output of type string. So if we define the function, give it num, this parameter will be of type integer is equal to, for example, um, we are given a number. Now, this is a valid function in Clean, a very valid function actually, and this is its function signature. Now, the function signature here tells the compiler that we will be expecting an integer as an input, and the output will be a string. There is no other way that this function will be accepting any other inputs rather than an integer. So if you start by calling the function and give it, for example, 3 and run it, um, it outputs the correct result. However, if we give it, for example, a character, let's say some character C, for example, or 5, and we run it, it gives an error because it's telling us that this function over here is expecting an integer and we gave it a character. Also, you can give it any type. You can make this function very general in this sense that it can take any type. It doesn't matter the type, but the output is a string. So here it can be arbitrary. You can run it. Now, um, the output is what matters. The input can be of any type. The output is what matters. Now, you can literally write anything here, something, it will work the same because you're telling the compiler that okay, we are expecting any type in the input, but the output will be a string. Now, this function is very general, okay, and trying to overload this. Let's say we want to overload this function. We want the definition of the function to act differently with respect to the type, to the given type. So if we have something here, if we have an integer here, for example, we want to output this result, and if we want a character to be given as an input, we want to output that this is a character. Now, let's run this function. It will give us an error saying that this function has multiple definitions. That's correct. We have this func over here and we have this func over here. The compiler does not differentiate that this given type is a character and it should be calling this function. It doesn't know that. The compiler is quite stupid. It doesn't know that. And it's telling you that I've seen this name before. This name is already defined here. So while you're trying to define multiple functions, it doesn't understand that the functions have different types and they output different stuff based on the given type. The compiler doesn't understand that. And then the people who are building the clean compiler decided that, okay, we can introduce a new concept to the language called classes and instances. Now, this is some kind of a patch to this problem. Kind of, you can think of it that way. It's trying to overcome this problem that we had over here, that we want the function to act differently regarding the input type. So um, we can define a class with a very simple way. So we say class, this, I'm going to explain it in a moment. We can say class, this keyword, and then you give it the function name per se. Um, some name, let's call it func again. Now, after this function name, you'll have to give it the types that you'll be using, like the unique types or symbols to represent these types by in the definition. So for example, let's say something. Okay, so it's okay. We can give a type of that. It doesn't really matter. It's just a symbol at the end of the day. So we have this function name and we have this symbol. Let's call it symbol one. Okay, to represent some incoming type. And then we can say, okay, this definition, this right here will be the definition of the function. Now, this is quite a resemblance of what we wrote before. Um, something is equal to string. This here kind of means the same thing that this syntax is trying to elaborate. So this thing is kind of like this, but not exactly like that. And the difference here in this syntax is that this is just a template for you to define the overloaded functions for. Since this is a template, this is some kind of a signature of the function, okay? And if you try to call it like that, it will not work. It will tell you that, okay, there is no instance available for the type character. That this thing here, instances, is the second phase of the coin to heal this problem, to remedy the problem of overloading the functions for different input types. So I'll dive into instances in a bit, but I want to make sure that this class syntax is quite clear. So we have the class keyword, and then we have the function name, func name, and then we have symbol one, two symbols maybe. Let's say we have two symbols, symbol two. So this is same as saying we have an arbitrary type 1, an arbitrary type 2. It doesn't matter if they are the same thing. It doesn't matter if they are different. We're just telling the compiler that this function can be defined, can be instanced for two types. Okay, we will go into instance definitions in a bit, but bear with me. So this is a function name. These are two given types that will be used inside the signature of the function to define the signature of the function. So we can say A, B, the function to expect A, B types, two inputs, and outputs a string. So if we try to copy this, let me actually illustrate it in a different syntax. This function signature over here means the same as this class signature over here. However, this is a more general term that we can use to instance this function for any two arbitrary types that we like the function to act on. So let's go into instances. So again, as I said, if I try to run the start again, it will give me an error that func undefined. Yes, sure, because I changed the name. And let me run it again. Start rule cannot be overloaded. Yes, because the function now expects two inputs, as we can see over here. Now these are the inputs. This is the output. These are the inputs. This is the input area, and this is the output area. These A and B are the types of the input. For example, we can make the function can be defined for a single type, and the input of the function um, types will be of that type. So just substitution. So we can say 5 now. It will work, and it will tell us that there is no instance available for the character type. So now let's define an instance. Let's go and define an instance. So what does an instance mean? An instance holds the definition of this function for a specific type. This is what it means. It holds the definition of this function, the body of the function, how the function will act with this given type. So we gave it a character over here, a type char over here, and we want it to act depending on the given type. So we need to instance it based on the given type. We want to say that, okay, this function will be created, will be instanced for, will be defined for this type. Okay, and here is where you put the function body. Finally, we are the function body. We are the function definition stage. So we can do func name, some character. I called cr earlier, and then I can write, for example, this is a given character. So by running this, we have func name used with wrong arity, or because it's expecting two inputs. Let's remove this for now. So now it is working. This is a given character. All good and smooth. Now let's try to insert a number here. Let's try to insert 1. And same error as we were getting earlier with the character before we defined an instance of the function for that type. We're saying here the compiler is trying to say that there is no instance available for type int because we gave it an int type, an integer. So we can define the function for integers and say this is a number, let's say, and let's call it this differently, and we try to run it, and then we have this is a given number, whatever. So the function now acts differently based on the given type. If the type is an integer, it outputs this is the body that gets activated. If the type is a character, this is the body that gets activated. Both of these bodies, this body, this function body, has to follow the same signature as the one in the class definition. So just to recap, we can define a class, we can give it multiple types. For example, we can give it A and B. Now this instance will show an error because it's expecting this function to be defined for two types. Now let's see, and we have wrong arity over here, and we have the same thing. It's saying that, okay, this function has to be defined for two given types. It doesn't matter, we have to define it for some type and some type. We can make it int and int. It doesn't really matter. Now everything, um, of course, here we have the same problem. And finally, B wrongly used or not used at all. The compiler is smart enough to know that B is not used in the function itself. So it's telling you that, okay, you have an error with this one. However, if we try to use it over here, let's just choose it. Okay, let's just um, say that, okay, we have something, we don't care. Let's just make it like this, like this. We don't care about whatever is there. And then we have to insert something here. So let's insert anything actually. We do not care. And we give the we get the same output. So to recap, again, we have a class. This is the class signature. The class before the colon, we define the class name and the substituted types, the types that will be used within the body, within the function itself. And then this is the function signature, which defines how the function behaves, what inputs does it take, what type of inputs does it take, and what output does it result in. So we have instances, we have classes, both are covered, but the main reason of why we have this is to overcome the problem of overloading functions. Um, there is one last thing I want to cover before I go into complex classes because we have something else called complex classes. I just want to cover some additional thing before we jump into that. There is some additional thing to classes. Okay, classes can be used to describe additional features of given inputs. So far you've known that you can add some additional information in the function signatures. For example, if we have a func, okay, and it takes any type at all, we do not care about the type. The type is very general, and it outputs some string, for example. Now we have this pipe that you can insert here to give restrictions on where to call this function. So when to call it per se, not where, because this any type can be restricted to some certain types. And we can do that actually by saying that, okay, the func name has to be defined for the given type. So this function over here, okay, will take any type at all if and only if the func name has an instance for that type. So for example, let's say we have func, we have n is equal to the most general of all. Now we have this string over here. Now let's call this fun. As you can see, it runs smoothly, no problem at all. Now let's give it a character, for example. Say it runs smoothly again, no problem at all. Now let's give it some new type per se. Let's give it a list, for example, of 1, 2, 3. Now this will show an error. As you can see, it's saying that func name no instance defined for this given type over here. So this pipe restricts the given inputs um, to the definition of the function. So if the function is defined for the given input type, then this function is runnable, compilable per se, not runnable. So this is all I wanted to cover about the basics of classes. Now I would love to go into a bit of a depth explanation of complex classes. Complex classes are the same as this, the same as the simple classes. However, instead of holding only one function, you can have a bundle class per se. So we can define a bundle class, okay? And let's say Mojido's bundle, Mojito bundle or package, we can say underscore package. The naming here does not matter, okay? And it can be defined for one type, okay? And then we can do a where, and then we can have some function signatures over here. Now, let me give some space, and then we can have some function signature over here. Now, what I mean by function signature is the same thing as we were having over here with this thing. So we're saying that, okay, for this bundle, any type, any instance created for any type, like these instances, any instance created for any type. So we define this bundle for the given type, then the list of functions must be defined also for that type. So we can say func name 1, func name 2, something, some func, and equal to end. So it doesn't really matter. What we are saying over here is that, okay, we're having this kind of package of functions, and when we instance a new and when we instance this bundle or this functions, this huge pile of functions to a single type, then we have to define these functions, all of them, for that given type. So let's try to instance something. Instance Mojito package bundle, whatever, for example, end, then we have to define all of these functions. Now let's copy them here and start filling them up. As you can see, we have defined these three functions here. These three are the function bodies of these signatures inside this bundle, which is instanced for type integers. So now all the A's over here will be of this type. And this given type A is substituted with integer. So now we can say that the compiler under the hood is substituting all the signatures with integers instead of A, and therefore A over here is an integer. So any function that is defined for type integer can be also run um, for type A. So let's start this out. Start is equal to we have func name. Now func name is defined for type integer. So when you do not need you cannot write it like this, of course you cannot write it like this. This is not a function. This is a bundle of functions. So you need to directly go and call the functions for this type. So we give it one func name, it works, func name. Now we give it a character, let's say C, and we have an error telling us that this bundle is not defined. It's not telling that exactly. The error must be saying that, okay, this func name belongs to this bundle, and this bundle is not defined for type characters yet, because we are going to define that. So now we have type int, because it returns an integer, of course. My bad. The given is a character, and then the output must be an integer to respect this signature over here. So we try to run this, and it works beautifully. Now, this is a complex class, and same, it can be also used in function signatures. For example, we can say func for any given type, it outputs a string, and this function is only compilable for A's that are defined with the my bad for Mojito bundle package class or instances that are defined for type A, for any of type A. So again, let's just illustrate this point. So we have C is equal to, this is the most general, and then let's call it. Now, as you can see, this is a C. C is of type character. Character is substituted instead of this A, so it will be something like this, since this is a character. So character, character, character. Now we are saying that, okay, this function will only be compiled if this class is instanced, um, so it has an instance for this type, which is a character. If we substituted if we go and do the whole substitution. So Mojito is technically defined for type characters, so this function will run, and it does. Now let's say that we are giving it a list, back again, list, and we run it, and same, no instance available for type int, lists of integers. So complex classes is just a simple way of saying a bundle of functions that must be instanced for this given type. Simple classes just saying that, okay, this is a class that only holds one function, so we don't need this kind of cool way of doing stuff. So we're not defining a bundle, we're defining just one single function. The class name can be the function name here, while here the class name is different, and it can be. That depends on the implementation, the way you want to implement it. It can be same as the function name, it can be different. Here, when you define a simple one, it's always the same as the class name, the bundle name per se. So we can define a bundle with one function. We can do that. So this is what I have, and now let's start with the class with 1, and we give it, for example, 3 or 1, and it runs. So here the class bundle can be the same as the function name, and when we do it this way, when we do a bundle of one class with the same name, we can just skip this headache and write it this way. This is what is done under the hood. So when you write something like this, what the compiler is really doing is that it's transforming it kind of like this. So you can always think of simple functions as this, or you can think of it the opposite way. It doesn't really matter. The most important thing is that this class is a general signature, and you can define the function to behave differently for different types, for different given types. And if that type is not defined, then there will be an error, of course. That's all what I have to record for this consultation. It's a very short one, a very brief one. I hope I explained everything regarding classes and instances. It's a very simple topic. It's a bit tricky when you try to think of it as an object from an object-oriented aspect per se. Like most of the time, you are asked to do an instance of this type, for example, smaller than or larger than. Um, Smaller than or larger than are defined in the language. So if we say smaller than, let me highlight it. Oh, my bad. Let me highlight it, search for it, and then we have the class definition. This is the class definition. So let me copy this. The infix over here means the infix in the definition means the priority of the operator of the function. And it means the strength as well. For example, we can have a multiplication, and the multiplication in mathematics is always stronger. It comes first, always, um, with respect to addition. So if you have something like 3 or 1 multiply 2 plus 4 equal to this is this will be multiplied first, so we will have 2 plus 4, and then we will have equal to 6. So the multiplication was resolved first, and then the addition comes next. This is all what it means. So if we look again to the not here, my bad. If we look again, we have the smaller than is of strength 4, and then we have the multiplication is of strength 7. Strongest among all of them. Actually, the strongest is the not. I think the not is 8. So back to we can define instances of this class. So we have predefined classes in the language, and they are defined for certain types. But for example, if we have our own call type, for example, a tree is not a built-in type in the language. Therefore, if we want the less than operator to work on trees, we will have to instance that ourselves. We will have to define this operator for trees ourselves, and we can do that same way as we're doing over here. We can do, for example, of type, I don't know, for tuples. Um, we can do. By default, this is defined also for tuples. I'm not quite sure of it. I think it is, but let's check it out. So we have start is equal to tuple 1 2 smaller than 2 3. Okay, it's defined for tuples. What about let's say it like this, and then we do and then we expand this a bit, change this to z z f f. Run it again. Hallelujah, it works. Magic. Not really. If you understand the classes, if you understand that you can define it literally for whatever type you created, whatever anything that you've created, then it's not magic. Becomes obvious. And here is what we have. So that's all for this recording. I will try to squeeze it as much as I can, get rid of the unimportant stuff and keep the essential ones. Have a nice day and good luck on the exam coming on the 4th of May.